Hello everyone, this is lesson 21. We want to do antiderivatives and indefinite integrals. Okay, so we can see anti, right? So anti, we know how to derivative of the function, right? So then what is the antiderivative? It's undoing derivative. Okay, then let's think about that. This is a derivative of function, which is 4x to the third power. Now, we want to find out the original function, right? So, what is undoing for this one? So, think about that. Something derivative, then to make x to the third power, right? What will be? X to the fourth power, very good, right? So if we want the derivative, then we get the 4x to the third power, right? What about this one? How about 4x, 4 to the x power, 4 to the x power, x to the fourth power plus 3. Yeah, we want the derivative, what do you get? So we get 4 x to the third power for the second term. I'm sorry, I'm crazy. For the first term, and second term we get 0, right? What if we have x to the fourth power minus 7, right? We want the derivative, then what do you get? First term, it's a 4x to the third term. The second term is 0, right? What if we have x to the fourth power plus pi, yeah? We want the derivative, same thing, right? And second term is 0 because pi is the constant, right? So we can express, we don't know what exactly original function for the constant function, but when we derivative, let me write down, note, derivative of constant function is 0, right? So we don't know what exact of the constant function. So we denote like a C as a constant. Okay, then we can express f of x, which is x to the fourth power plus c. C is constant. All right? Okay, second one, we have f prime of 5x to the fourth power. Now, we want to find the original functions. Okay, so think something prime to make a 5x to the fourth power. What is that? Oh, yeah, you can say that. There's x to the fifth power plus c. Okay, we can check that, right? We check x to the fifth. Any constant equal to 0, so we can just consider x to the fifth power. Then we get 5x to the fourth, right? Very good. Next one, x to the sixth power. Think something derivative to make x to the sixth. Okay, now, we don't have a coefficient in the case. Oh, All right. What can you think? Yes. Think about this. F of x equal to, we knew there is a 7x to the 7 power. Normally x to the 7 power, right? Okay. Then if we derivative, that's 7x to the 6 power. So we have to get rid of the 7, right? How? 1 over 7. Yes? Okay, let's check that. 1 over 7, x to the 7 power derivative. Then we keep the coefficient, drop the power, which is 7, reduced by 1. So we get x to the 6th power. We simplify, then we get x to the 6th power, right? You guys okay with this? Okay, next one. X to the 4th power, same concept as earlier. So g of x equal to 1 over 4, x, no, 1 over 5. Yeah, 1 over 5. X to the 5th. Oh, we need to add plus c, right? Plus c. Okay, let's check that. We have 1 over 5th, 1/5, x to the 5th power derivative. We keep the first coefficient, drop the power, reduce by 1 for the power. So we get 4. Then we can simplify. We have x to the 4th power, right? All right. Okay, now we have indefinite integral notation from antiderivative. So indefinite means okay, so we have indefinite integral notation. So let me see, indefinite integral. This means we have that integral notation. This is integral notation. But then we don't see any numbers here. So we said indefinite integral. If we have some number 0 to 1, those kind of things, definite integral. Okay, so once again, this is integral sign, integral notation, right? So this is integral notation. Integral sign. And then we have the number. So for example, if we have like previously 4x to the 3rd power, right? So we have 4x to the 3rd power. And then we have dx. So that will be f prime of x, yeah? So we have this name, integrand. And then the process of find, let me write down. The process of finding an antiderivative is called integration. Okay. Then we can answer this one. X to the fourth power plus C, right? That's the answer. Okay, now I want to tell you about the formula. Since we did that previously, how did we find? We guessing, right? But then by the pattern, we can realize that everything we add 1 for the power and divide by new power, then we get the antiderivative. Make sense? Okay, let me write down here. So we want to make x to the n. We want to integrate, then x to the n plus 1 over n plus 1 plus c. Okay, let's check that. Let me write down here because we have a same questions at the end. Copy. Okay, so let's take a look. We have integral for x to the third power dx. We knew this is f prime of x. Okay, now how do you find the antiderivative or integral, right? So we knew we had the answer only, but let's think this way. This way, we add 1. So x to the 3 plus 1, we have a 4, and 3 plus 1 plus c. Okay, so there will be 4x to the fourth power over 4 plus c. There will be x to the fourth plus c. So this is the same answer what we had earlier, right? Okay, how about this? 5x to the fourth power dx. Okay, so we keep the coefficient x to the fourth plus 1 over 4 plus 1, right? I am following this plus c. But we had answer already, right? Previously. So 5 x to the fifth power over 5 plus c. Then there will be x to the fifth plus c. Okay, now we have x to the sixth power, integral x to the sixth power dx. Then we add 1 for the power, divide by new power plus c. So there will be x to the 7 over 7 plus c. Yeah, same answer as earlier. How about this? We have integral of g of x to the fourth power. Dx. So there will be x to the fifth power over 5 plus c. Is it okay? All right. So instead of we guessing, right? Yeah, we can use the formula easily by using power law, right? That is also power law for integration, for antiderivative. So this is power law for antiderivative. All right. Okay. Let's do this one. Oh, we have more. We have more example. Okay, then let me bring this one here. Up here. Okay. So we keep the coefficient and add 1 for the power divided by new power plus c. So there will be 8x to the fourth over 4 plus c. That will be, we simplify. So we have a 2x to the fourth power plus c. Okay, now we have 3 terms. So we should do term by term. So there will be x to the fourth dx minus 9x to the second power dx plus 3 dx. Okay, so the first one, x to the fifth over new power. Okay, let me write down this way first. 4 over 1, 4 plus 1, right? Minus, keep the coefficient, add 1 for the power. Okay, the integral of 3x. So this means 3x to the 0 power, right? Okay, then we can say that 3x to the 0 plus 1 over 0 plus 1. Oops, no integration. I'm missing c, right? So we can write down c, but overall we can make 1c. That's fine. Okay, then we have x to the fifth power over 5 minus 9x to the third over 3 plus 3x to the first power. We don't write down first power over 1 plus c. Because we need to simplify this one. Okay. So this is equals to 3, right? So we have x to the fifth over 5 minus 3x to the third power plus 3x plus c. Okay, let's do it. Once again, 3 terms. We do term by term. 13 dx minus integral 6x dx plus integral of 21x to the 6th power dx. Okay, once again, 13 is a constant. Same reason with here, the 3. This one, right? Let me write down here. Note. (13) dx means 13 x to the 0 power. Okay, so let's do it. 13, keep the coefficient x to the 0 plus 1 over new power plus c. And we keep the coefficient x 1 plus 1 over new power, or 1 over 1, 1 plus 1, sorry, plus c, and plus 21 x to the 6 plus 1 over 6 plus 1 plus c. Okay, so we get 13x and plus c minus 6x squared over 2 plus 21x to the plus c missing. It's okay, we can make 1c later. Plus 21x to the 7 power over 7 plus c. Okay, let's simplify. 2 goes 3, 6, 3 times, 7 goes 21, 3 times. So we have 13x minus 3x squared plus 3x to the 7 power. We can make 1c. Yeah, plus c. Make organize. Yeah, because too many c. Is it okay? All right, so we have application revenue. If marginal revenue in dollars per unit for month or for commodity is, have it like that, find the total revenue function. Total revenue. Okay. So marginal revenue is given, right? Now we do backwards. Backwards means normally we had previously we have revenue function. Then we are looking for marginal revenue. How? From the derivative of revenue function, right? But then this time we have marginal revenue, right? Means that this is R prime of x, right? With derivative of revenue function. Now with the backwards antiderivative, so that we can find the revenue function, right? So how do we make an antiderivative? Yeah, we do integration, right? Integral of the marginal revenue, which is the derivative of the revenue function, right? Very good. So let's do it. So MR, which is same as R prime of x dx, yeah, equal to, so that will be negative 0.05x plus 25, and then we make a dx. Okay, so we do one by one, term by term. So integral of negative 0.05x plus dx plus integral 25 dx. Okay, so there will be, we keep the coefficient and 1 plus 1 add the power divide by add the power, right? Okay, plus 25 add power over add power, right? Okay, so think about this. When you derivative, we drop the power, reduce by 1, right? We add 1, divide by the new power, right? So it's an opposite system, all right? Okay, then plus C. So we get negative 0.05 x to the second power over 2 plus, we have 25 x to the first power over 2. Oh, no. I made a mistake. So sorry about that. Yeah. 0, right? Over 1 plus C, right? Okay. So now, we're not done yet. What happened to C? Because we want to find the total revenue function. So what happened to C? So we need to solve for C. Or to solving. C. Okay. So every time in math, substitute 0 or 1 is the easiest one. So let's find out when x equal to 0. Set x equal to 0 means that we sell 0 items. Yeah. Okay. So if we sell 0 items, then revenue also equal to 0, right? This means revenue is 0, right? Okay, so we have look integral of the marginal revenue is the same as total revenue function, right? Okay, so we have total revenue equal to, we found this one, right? Total revenue function. Copy. Okay, then when x equal to 0, the revenue is equal to 0, r over 0 equal to, then everything is a revenue equal to 0, right? So we have negative 0.05 x equal to 0 over 2 plus 25 0 plus C. Okay, then solve for C. Then everything is 0, 0 plus C equal to 0. So C equal to 0, right? Okay, since C equal to 0, we can express this one. Only this one, right? Since C equal to 0. There is a total revenue function. It's okay? Okay, now let's do this one. Oh, very similar. Yeah. So we have just one more additional steps. You can do it, right? Okay, so we want to find, this is R prime of X. So we want to find revenue function, the integral of the marginal revenue, which is the same as R prime of X dx. Yeah? Okay, then there will be negative 0.006x plus 36. Then we do term by term. So negative 0.006x plus 36 plus 36 dx. Okay, so negative 0.006x 1 plus 1 over 1 plus 1, yeah? Plus 36x 0 plus 1 over 0 plus 1. Plus C? Okay, that would be negative 0.006 x to the second power over 2 plus 36x plus C. Now, let's find the C. Same concept. We set x equal to 0. That means no sell items. That means the revenue is 0. Okay, that is, we have R of X that, come on, copy. There will be the revenue equal to set equal to 0, right? So R of 0 equal to, so negative 0.006, 0, over 2 plus a 36, 0 equal to, plus C equal to 0, right? Yeah, this is so slow. Plus C equal to 0. So we know C equal to 0, yeah? Okay, then we have this for the total revenue function. Come on, let's go. So R of X. But then we want to know about the total revenue from sales of 75 units. 75 units. Okay, let's do it. So R of 75. Then we have negative 0.006, 75 squared over 2 plus 36, 75. Then we get the answer $2,683.13. Make sense? Okay, thank you for watching. Bye.